About 40 years ago, David Willard was working at the Field Museum in Chicago, this famous natural history museum, when he heard something strange.
A person at another institution in Chicago just mentioned casually that birds often hit the windows at the big convention center called McCormick Place, which is a building that's right on the lake and has a lot of glass.
So one morning in 1978, David went to check it out.
I walked down in the morning and just kind of blatantly trespassed around the building out of pure curiosity, not expecting anything.
And sure enough,
I found 3 or 4 dead birds around the edge of the building, having hit the glass, and brought them back to the museum.
David and his colleagues went back again and again, and they'd usually find more birds on the ground.
We'd walk around the edge of the building with a plastic bag for dead birds, and we would take 4 measurements from each bird, putting the information into big ledgers.
Over the last few decades, David and other volunteers have collected over 100,000 dead birds across downtown Chicago.
When I first started, it was just a thought that here are these dead birds, we might as well at least make them useful for research and bring them back to the museum.
But he started to realize this was a serious opportunity.
It was only as the sample grew that we realized there were a lot of interesting questions that could be addressed using them.
And when scientists examined this huge amount of data, they started to notice something weird.
Birds over the last 35 years have shrunk.
And this wasn't just one type of bird.
The most amazing thing that they observed is that on all of the species, whether it was a thrush, a warbler, a sparrow, they were showing this declining size. And the question of just exactly why is an open one.
I'm Noam Hassenfeld, and this week on Unexplainable, why are birds and a whole bunch of other animals shrinking? Okay, Benji Jones, you wrote about these shrinking animals for Vox. How much shrinking are we talking about here? Is this like birds are barely shrinking, or is this more serious?
It's pretty significant. So they found that birds on average over this 40-year period lost about 2.6% of their mass, and a part of their leg, which they used to measure the change in size, also shortened by an average of 2.4%.
Yeah, I assume those kind of changes, I mean, like a 2.6% change, we would normally expect to see that over like a much longer period than 40 years, right?
I mean, I think so. Like when I think about evolution, for example, in the animal kingdom, I mean, that often takes place over thousands of years, certainly not over 40 years. So it's pretty wild.
Is it only happening in birds?
It's pretty widespread. So it's not just birds that are shrinking. I've come across studies that show salamanders are shrinking over time, fish, wood rats, deer, sheep, common toads. There are lots of things that seem to be getting smaller over time.
Do scientists have any idea why animals are shrinking? What's going on here?
So there's no one answer for all these animals. There's still a lot we don't know, but scientists do have some guesses that might explain what's going on.
So what's the best guess we have to explain the shrinking here?
There's been a fair amount of research on birds and some studies on mammals as well that appears to link these shrinking animals to global warming, to climate change. Literally just the world is getting hotter, and that is what's causing this shrinking effect.
How does climate change make animals smaller?
There is this principle in ecology called Bergmann's rule. Essentially, across the range of a warm-blooded species, like a kind of bird or a kind of mammal, you will see smaller versions of that animal in hotter climates and larger versions of that animal in colder climates. One explanation for this has to do with how easy it is to get rid of heat. In a hot climate, it's just much easier to cool down if you're small. And you can think about it like recipes that call for softened butter, which always drives me crazy because I'm never planning ahead when I'm cooking. And so I'm like, damn it, I have to like soften this butter quickly. And I'll often like cut it into little cubes. and tiny cubes of butter soften faster because there's more surface area versus one larger stick.
So if you want to get rid of heat, it helps to be smaller and have more surface area relative to how big you are. And I assume not being able to get rid of heat is bad, right?
Exactly, in a hot environment because you would potentially overheat.
Where does this get complicated? Why is that not just, okay, case closed, it's getting hotter, animals are getting smaller?
One of the things that makes it complicated is that Bergman's rule applies to warm-blooded creatures. So these are things that create their own heat. But it seems that there's also this trend that cold-blooded animals, so things like insects and amphibians, are also shrinking in response to warming. So it's not just about warm-blooded creatures.
So Bergman's rule wouldn't explain why some cold-blooded animals are also shrinking.
Exactly. And when you start to ask kind of why, that's when there are lots of different theories that potentially apply, and we don't have that great of an idea.
Why could cold-blooded animals be shrinking?
So if you look at something like frogs, what researchers have found is that when it's hotter, their metabolism speed up. That means that they are actually kind of growing faster, transitioning through life stages faster. So a frog goes from tadpole to baby frog at a faster rate, which just means that they are smaller by the time that they're adults and they don't grow much beyond there.
Okay, so is that the only thing that makes this shrinking animal question kind of hard to answer, that both warm and cold-blooded animals are shrinking?
Well, some animals are actually not shrinking and getting bigger as the climate warms, according to some research at least.
What kind of animals are getting bigger?
Yeah, so there hasn't been a ton of research, but I have seen a couple studies. One was on the American marten, which is this cute ferret-like animal, and then another was on the Eurasian otter, also a very cute animal. And one theory for why they could be getting bigger is that there's either more food available because there's longer summer or spring periods where food grows, or it could even be just because they're spending less energy trying to keep themselves warm because it's just more of an ambient, comfortable temperature outside.
Okay, so then why wouldn't that just lead to birds getting bigger too?
Yeah, that's a really good question. So it's just really hard to say why there is this variation. I think these examples are just helpful because they kind of poke a hole at this being this overall effect of shrinking. Like, it's just not the case.
So it seems like global warming could be changing the shape of animals over time, but we don't really know which rules apply to which specific animals and exactly how they apply. That's all, still unknown.
Yeah, I think that's a good way to put it.
And for the animals that are shrinking, do we know if we're watching evolution happen here? Like birds are evolving to be smaller, that somehow it's better for them?
Yeah, so that's the other big unknown, right? Like, I have seen some research that suggests that this is an evolved trait for some birds. In some way, being smaller is going to benefit them in a warmer world, which gets back into Bergman's rule. But for some animals, we know that when it's warmer during their development, they'll just get smaller. So that's not evolved. It's just happening as they're growing. So for frogs, for example, and other amphibians, that seems to be the case. And we know this because scientists can alter the temperature in a lab setting, for example, while they're just growing these different animals. And they see that they just don't get as big.
Got it. So this isn't passed down to future generations like Bergman's rule, right? This is just happening to these particular hot frogs.
Yeah. And that would be what scientists call a plastic change. And so for cold-blooded creatures, it seems that these kind of within lifetime changes might be responsible for the shrinking effect.
And I assume it's important to figure out kind of which one is happening here, whether a certain shrinking is evolved or whether a certain type of shrinking is during an animal's lifetime, right?
Exactly. And so if it's happening during an animal's lifetime, such as with frogs, that definitely can come with some serious consequences. When it's evolved, like what scientists think might be happening with birds, it's probably a little bit less scary, but it's important to keep in mind that there are still limits of adaptation, and the climate is warming really, really fast right now, much faster than it's warmed in the past. So can these birds evolve to live in warmer climates fast enough? We don't know. And even more importantly is that some animals are getting smaller at a faster rate than others. Some animals are even getting bigger, and that creates big problems at an ecosystem level.
Do you think more and more animals are going to start shrinking, or is this just too hard to predict?
Yeah, this is a question that I feel like every time I write a story about how climate change intersects with biodiversity, I get to this point in the story where it's climate change is having way more complicated impacts than we imagined, and they're really hard to predict. And I feel like this is a perfect example of that. Like, it's so hard to understand how warming temperatures are going to affect these really complicated ecosystems. And so trying to predict what will happen to a given species is really, really difficult.
After the break, we try out some really, really difficult predicting. And not just 40 years in the future. We're going much, much further. That's next.
Birds, 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 birds.
It's Unexplainable. We're back, and I'm here with producer Mandy Nguyen.
Hey.
Mandy, you've been hard at work producing this Shrinking Animals episode, and when we left off, we were talking about how hard it is to predict how these animals might end up changing in the future.
Yeah, but I really wanted to try and predict it anyway.
Okay.
Obviously, it's hard to predict the future, and it's harder the further you go out. But I spoke to a bunch of scientists about what future animals might look like, and I had some fun with it, and I made a little nature documentary of the future.
Okay, let's hear it.
The Earth, millions of years in the future. This blue planet still teems with life forms, but humans are not among them. Our dominion has ended, and other creatures have filled the open spaces that we have left behind.
The vast pools of carbon dioxide that we produced were retained in the atmosphere for tens of thousands of years, and that has resulted in a renaissance of green plants. And then without humans around to harvest them, plant life has flourished and diversified, and so we now have an atmosphere that's richer in oxygen than the one that we have now.
Plants have flooded the atmosphere with oxygen, reshaping life on the Earth's surface. Insects are especially affected.
Insects breathe not with lungs like we do, but with tiny tubes called trachea that are found throughout their body. And researchers hypothesize that after insects reach a certain size, they can't get enough oxygen through their trachea because of a problem with surface area to volume limitations.
But with more oxygen in the atmosphere, those limits may not apply. This is what happened millions of years ago in the late Carboniferous period.
Around 300 million years ago, we know there were dragonflies that were around the size of hawks and ants as big as hummingbirds.
Now, in the world of the future, history repeats itself.
Imagine that you're in a tropical forest in the future. As you stumble through this forest, all of a sudden you see an animal that you recognize as a praying mantis, but one the size of a cocker spaniel. It has all the same features as the praying mantis that you know, triangular head, the large compound eyes that are following you around, but it's just much, much bigger than you're used to.
The praying mantis crouches, camouflaged against a tree trunk. Motionless, she lies in wait for her prey.
It can hunt small to medium mammals, it can hunt lizards, birds, and even fishes, but actually specializes in giant cockroaches that roam the forest and are around the size of Pomeranians.
A herd of cockroaches amble by, their long antennae prodding the forest floor. One of the roaches strays to the side, unaware of the hungry mantis. The praying mantis flashes her claws and grabs hold of the flailing roach. Her grip is strong, and she takes a clean bite out of its head. A delicious victory. But the world of the future has more than just insects. Since the Anthropocene, many large mammals have gone extinct, and in their absence, survivor animals like rats have taken center stage.
The groups of mammals that do survive, like rodents, are going to occupy the ecological niches that are vacated by all these other animals.
Animals like whales and sea lions. These marine animals, many of which have gone extinct, evolved from land-dwelling ancestors.
Like seals and sea lions seem to be two different independent lineages of mammals that evolved to be aquatic and semi-aquatic, respectively.
What was once an ocean devoid of large marine animals is now home to creatures displaying evolution's creativity. Creatures like the whale rat.
So this whale rat has evolved to become fully aquatic. So it's lost its fur, it's lost its whiskers, it's all gone. Its tail has maybe become more like an eel's tail. It's become really compressed so it can help with swimming. And its arms and its legs have both evolved into flippers.
In this future world, whale rats are the size of porpoises, sleek and fully at home in the water. The coastlines in spring are a playground for restless young whale rats. The pups tussle in the shallower waters while their families rest nearby. High above them, a bat spreads its 6-foot wings and soars over the waves. But this is no ordinary bat. This is a sailing bat.
It's a bat that lives in the ocean and has evolved a very extreme anatomy to sail and soar on ocean air currents for very long distances.
Years of sea level rise have forced this bat far out of the niche occupied by its ancestors in search of a nourishing meal.
Their wings are long, narrow, they're stiff, allowing these bats to glide.
To conserve energy, the sailing bats glide instead of flap, traveling sometimes for hundreds of miles without landing. As they soar, they chatter at the waves, listening for their next meal.
They have long faces with conical teeth that allow them to snatch prey off of the surface of the water as they forage for aquatic prey using a very sophisticated echolocation system.
The sailing bats catch the ripples in the water made by the young whale rats and descend for a closer listen. As they approach, they send out fewer pulses of sound with large intervals in between. They're listening for the exact location of their prey. The whale rat pups have given themselves away. The sailing bats dive, snapping their long mouths at the water's surface. The sailing bats make short work of the whale rat pups. Soon, they soar off again, traversing across a planet that is still rich with wonders. Wonders that may be familiar to us, or perhaps entirely different.
And this is the beautiful thing about evolution, because, you can have the same starting conditions and just one little change to the DNA, one little happenstance about what predators are around, what pollinators are around, and it can change everything and the course of what's going to happen over the next many millions of years.
That's as far as I got, but I hope you enjoyed it.
I mean, that was amazing. I loved it. But how realistic is this? Is this science fiction or is this kind of reasonable prediction?
It's definitely more speculation than definitive prediction, but a lot of the scientists' answers were rooted in science. I posed the question as something that was like a fun and interesting question, but I was pleasantly surprised at how seriously they took this question.
When scientists are thinking about a question like this of what animals could look like in the far future, what's their starting point to answer a question like that?
They approached it in a few different ways. Some started by thinking about what animals they thought was most likely to survive that far in the future. So this is where the rats came from.
Yeah, they're just really good survivors, right?
Yeah, so they're hardy, they do well living with humans, and they're probably going to make it. Some other scientists, they started by envisioning what the future environment would look like and then working backwards. And that's how we got animals like the sailing bats or the whale rats with things like rising sea levels.
Or like the huge insects because of the high oxygen levels.
Exactly. And some scientists, when they were answering this question, some of them went completely outside of Earth.
Like aliens?
Not aliens in this case. We're still talking about life from Earth. Specifically, we're talking about slime molds.
Slime molds?
Yeah. Slime molds are these weird organisms, like they're not a plant or an animal or a fungus. And the scientist I spoke to, her name is Tiffany Taylor, she was speculating about a future where humans brought slime molds to Mars.
They were taken to Mars as part of sort of early experimentation, but unfortunately there were a few escapees that managed to get out onto Mars's surface and explore.
They're already these really strange creatures and can take so many shapes and forms, and they might become even weirder on another planet.
Should they encounter an organism that they need to run away from, they can change their shape such that they might acquire legs and might start, running off very quickly. So their adaptability is absolutely their strength. They have no set form. They can adapt to whatever their environment requires.
Wait, these slime molds are sprouting legs in this scenario? Are we still in like real science mode?
We were definitely getting a little sci-fi and joking about the slime mold sprouting legs and running away. But it was really fun to think about how life might evolve away from Earth, because those processes are not something that we really know about at all.
Yeah, Darwin never got a chance to figure out what would happen on Mars.
Yeah.
There are all these different ways that scientists are answering this question. It certainly sounds like they had tons of fun answering this. But you also said they took it really seriously. Like, what is the ultimate point of this exercise? Is it just sort of like a way to stretch our brains about what's possible, or is there something more important here?
Yeah, I was also curious about what scientists took away from this exercise. And one of the scientists, Liz Alter, she gave me an answer that I really liked.
So evolutionary biologists are very used to thinking about long timescales in the past, but it's somehow a lot harder to envision the future, which is interesting. And I think that's, it's partly because humans have just been this tiny blip in evolutionary history, right? Our species is only, a few 100,000 years old, but in that short time that we've been on the planet, we've completely altered these basic aspects of geochemical cycling. And so as a consequence, how evolution proceeds for the Earth's inhabitants has changed as well.
Life is probably going to persist, and any future animal or ecosystem that exists is going to be impacted by what happens today.
It makes it a very sobering thing to think about the long future, what that long future will look like. But I do think it's a really useful and important exercise, especially because we're at a point as a species where we're going to have to make some hard choices to avoid a future Earth that's uninhabitable, at least for us.
No one can say what the future's going to be. So I think it's worth then asking, what future animal and future environments do we think might exist? What future is possible?
I think that it would be really, really cool to see giant bugs. But it would just be nice if humans are actually around to see them.
Thank you to all the scientists who spoke with me for this episode, including Liz Alter, who spoke about the giant praying mantises, Jingmei O'Connor, who talked about whale rats, Charlene Santana, she spoke about the sailing bats, Tiffany Taylor, who brought the slime molds on Mars, and Julia Sigwart, who shared some big reflections on evolution. And an especially huge thank you to James Barham, our very own David Attenborough. This episode was produced by me, Manning Nguyen, with help from Meredith Hodnott and Bird Pinkerton. There was editing from Noam Hassenfeld and Brian Resnick. Scoring was done by Noam and Meredith. Fact-checking was done by me. And the sound design was from the always brilliant Christian Ayala. Lauren Katz heads up our newsletter, and Liz Kelly Nelson is the VP of Vox Audio. We spoke to a ton of scientists for this episode, and we didn't have space for all of them. But I just wanted to give a big, big thank you to Corey Evans, Tanisha Allen, Alexis Mikhailo, Jessica Ware, Myrene Belisi, Sahas Barve, and Danielle Edwards. You can sign up for our newsletter at vox.com/unexplainable and email us any thoughts that you might have about the show at unexplainable@vox.com. Unexplainable is part of the Vox Media Podcast Network, and we'll see you next week.